Okay, YouTube, in this video what we're going to be doing is focusing on the properties of inverse trig functions. And essentially, these properties exist just like any other inverse functions. We say that if you were to take the inverse function of a function value here, then we would just get, the original input here. Or we could take, f of f inverse, and I'm just going to put like an x value here. But I'll say you just get some x here. Basically, the fact is that inverse trig functions undo one another. And so one thing that we want to be really, really careful with here is this. When we take inverse trig functions of one another, we say that these arguments cancel out. That's very, very true, but we are restricted on what we can get out of these things. And that is to say that, remember, when we use an inverse trig function of another thing here, then we are restricted on the outputs that we can get depending upon what inverse trig function we have. So taking a look at these, what I want to do is run through and evaluate them, being careful of what we spit out of them, and also classify our answer as either a trig value or an angle. So when I look at something like number 13, the first thing I want to recognize is that this inner portion right here, let's see if I can actually highlight that there. Get my pen tool back out, hopefully. This inner portion right here, this is an angle. And so what we're doing is we're taking the cosine of some angle, and what you have to realize is that this gives us a trig value. So the first thing I want to indicate is that what we're finding here is a trig value. And the interesting thing about trig values is that they're fabulous. When you take the cosine of an angle here, it doesn't matter what angle you take the cosine of, you'll always get an output. And as long as this is some value between -1 and 1 here in our r cosine, basically what I want to get at is that the r cosine and the cosine cancel out and you just get left with a half. As a matter of fact, this is going to happen anytime that we take a trig function of some angle here where these are inverses. We're going to get cancellation. So for instance, on 14, you notice that we're taking a sine inverse of the sine of pi thirds. That's not the same thing as taking, say, a trig function, a normal trig function of an angle. In this case, we're taking an inverse trig function of a value. And this is our value right here. And so really what we're going to get out of this is we're going to get an angle. And so to recognize what it is that we're finding here, we get an angle. And we're going to be restricted on what our outputs are. But say something like number 15 here. Number 15 is I notice I'm taking the tangent, which is a normal trig function, of the tangent inverse here. Because we're taking the normal trig function of the angle here, or the tangent inverse, these should just cancel out and we'll get left with root 3 over 3. So I hate to spoil the surprise, but basically anytime we take a normal trig function of its inverse, like the sine here of the arc sine where they're inverses, so we take the sine of this angle, we're going to get cancellation. We should just get 1. As a matter of fact, cosine of arc cosine, we're just going to get root 2 over 2 because they're inverses. And tangent of arctangent, of course, you get just root 3. Now, going back and looking at these remaining ones, these were all trig values, okay? Value, a trig value. We were all on all of these that we just evaluated here. We were taking a trig function of an inner angle, and they just happen to be inverses of one another, okay? So we get a trig value whenever we take a normal trig function of an angle. When we take now an inverse trig function, of course, like I mentioned over here, of a trig value, then we're going to get an angle back. And so the important thing to remember here is this. With respect to sine inverse, remember that sine inverse will only ever give us an angle back between -90 degrees and +90 degrees, or negative pi halves and positive pi halves. I'm actually going to go ahead and say that tangent inverse is very similar to sine inverse. The only difference is you can't include positive and -90 because it's undefined there. And with respect to cosine inverse, it's got to give us back an angle between 0 and 180 degrees. 0 and 180 degrees, or 0 radians and pi radians. And so what we look at here, when we say the sine inverse of the sine of pi thirds, what do we get here? The simple fact is, if I were to just cancel these out, which I'd love to do here, I would get pi thirds. And the fabulous thing about that is it's actually pi thirds. As a matter of fact, pi thirds, if I say, where's pi thirds? Remember, pi thirds is like a 60 here. I would say, here's a pi third. But what I want everybody to recognize is that pi thirds is actually between negative and positive 90 degrees. So we have no problem doing this. It's just that when we get to something like number 16, where we're saying, hey, what's the cosine inverse of a cosine? So we're taking an angle of a trig function value here. So we're finding an angle. Need an angle here. An inverse trig function of something is an angle. But we're saying of the cosine of 3 pi. And so what we're going to have to do is this. We're going to have to get used to the fact that we're going to have to evaluate the inner function. Evaluate the inner function first. And so what this means is we're just going to go find the cosine of 3 pi. And the nice thing about that is, I got my unit circle right here. We say 3 pi, there'd be 1 pi is 180 degrees, 2 pi 360, 3 pi is 540. But basically, what's our cosine value at 3 pi? We can see it's -1. And so after we've evaluated this and we rewrite this, we say cosine inverse of -1. Now, notice that what I'm asking is, what angle, here's cosine inverse, what angle between 0 and 180 degrees gives me a cosine value of -1? And I'd say, well, between 0 and 180, -1 is our cosine value at pi. So what we end up with here is this. We get pi or 180 degrees, but you notice that really it's kind of like the same angle. We get that cosine value of -1 at 3 pi, but we also get it at pi. It's just that pi is between 0 and 180 degrees, and cosine inverse is only ever allowed to tell me angles between 0 and 180 degrees. So taking a look at 17, obviously we're taking an inverse trig function of a trig value, so what we're going to get here is an angle. We're looking for an angle. Now we say, what is the tangent at 3 pi fourths? Okay, well 3 pi fourths is 3 45-degree angles. We say, what's our tangent value over here? Well, I know that because this has a reference angle of 45 degrees, and anything with the tangent of any tangent of a 45-degree reference angle is 1, I know that I get 1 over here for my tangent at 135. It's just that with y divided by x over here being positive divided by negative, we get -1. So again, here's what I've done. I've taken the time to evaluate my inner function first. I say, you know, that's -1. And I say, okay, so now, what angle between negative and positive 90 gives me a tangent value of -1? I know that it has to be at -45-degree rotation right here. So we'd say negative pi fourths, or -45 degrees. And you see how that's different than this? They don't just cancel out. We have to get an angle between negative and positive 90. So taking a look at this, we say an angle is what we're looking for. We have the trig function value, or at least we'll have that here in a second, but what we're getting here is an angle. So when we say the arc sine of sine, I'd love to say that these just cancel out, but remember sine has to give me an angle between negative and a positive 120 degrees. So looking at a negative 120-degree rotation, that would be going clockwise 120 degrees. You see that our sine value down here is -√3/2. So really the same statement can be rewritten as the arc sine of -√3/2. And now I'm asking, okay, so what angle between negative and positive 90 gives me a sine value of √3/2 negative? And if you know your reference angles, you know that sine is, √3/2 at a 60-degree reference angle here, and that this is going to be a -60. But looking at the unit circle, we'd say, okay, what angle between negative and positive 90, looking at all the sine values here, look at all the y values, we're saying which one gave us an arc sine, or a sine value of √3/2 negative. And so negative √3/2 is down here at what would normally be called a 5 pi thirds, but we're saying it's a -60-degree angle here. So we get negative pi thirds or -60 degrees. Cheers.